Welcome to this episode of Robert's Creative Chronicles. So today we are going to discuss about the standard differential coefficients table. Now, in this table, there are various functions and their derivatives. It is very important for you to know the derivatives of all these functions before you differentiate any function. So I strongly advise you memorize the derivatives of all these functions before you even start differentiating any function. Now, the first function is x raised to the power of n. The derivative is given by multiplying the power by the function, then subtracting 1 from the power of the function. So, you multiply the power n, which is n, multiplied by the function x, then you subtract 1 from n, which is the power. This is used to differentiate functions like x squared, whereby the answer will become 2x. So you use this to differentiate any function raised to the power of a number. So the second function is exponential x. The derivative of exponential x is still exponential x. It doesn't change. The third function is exponential kx. The derivative is given by differentiating the power, which is kx. You differentiate kx to give you k, and then you multiply the derivative by the whole function. You know, here above, the derivative of x is 1. So if you multiply 1 by this function, it will still give you this function. That is why the derivative of exponential x is exponential x. This one, there's a value attached to it. So if you differentiate it, maybe from 2 going up, it can also even be negative number. So if you differentiate it, then you multiply that value that you got from the differentiation by the entire function. That is why it gave us k exponential kx. The fourth one is a raised to the power of x. So the derivative is a raised to the power of x in a. This ring is the natural logarithm, which is natural logarithm with base of e. Yes, it is like log with base of e. That's the ln, the ring. So the derivative of ring x is 1 over x. And then the derivative of log x base a is 1 over x ring a, or 1 over x multiplied by log e base a. Because the inverse of this natural logarithm of a is this log e base a. That's why this function and this function is the same. I just found the inverse of this ring a to give us this. So that's the answer. So this is the same as this. So anywhere you write this, you can also write this. Same thing. Now, sine x. The derivative of sine x is cos x. The derivative of cos x is negative sine x. The derivative of tan x is sec square x. The derivative of cot x, you know, cot is the inverse of tan. So its derivative is negative cosec square x. Sec x, the derivative is sec x tan x. Sec x is the inverse of cos. So this derivative is sec x tan x. Cosec x, the derivative of cosec x, negative cosec x, cot x. Cosec s is the inverse of sine. Then this one, this number 13, it is known as the hyperbolic sine of x. It's pronounced as shine. So the derivative of shine x is cos x. Cos x is the hyperbolic cosine of x. It's pronounced as cos, not cos. Cos x. And this is shine x. So the derivative of cos x is shine x. So that's basically all in this table. So please make sure to memorize this table. I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email within the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share, and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.